Good day. My name is Chris Allen and I am your geometry teacher. Today we're going to have our first video lesson. So hopefully this will work out well. I'm going to try to keep the lesson down to about 10 minutes. Today we're going to look at section 1-2, which is on points, lines, and planes. These are some fairly basic concepts that I would imagine that many of you are already kind of familiar with. Our objective is for students to be able to understand basic terms and postulates of geometry. So our first term, which is technically undefined, and the reason it's undefined is because when you try to define it, you find it ends up, you have to circle around it. We'll talk about it in class, but you actually can't define it. You guys probably already have a pretty reasonable idea, though, what it means when I say the point A. So if we look here at this picture, we can see that we've got down here, we've got this point A. Oops, my marker's not working here. There we go. Go back. Okay, so here's this point A. It indicates a location, but it has no size. So that dot there is what we use to represent the point A, but that's not actually point A. Point A is actually so small that you wouldn't even be able to see it. We label it, we name it using a capital letter. So that would be called point A. The next term, which is also undefined, is that of a line. So down here we've got a diagram of a line. A line represents a straight path that extends in two directions, opposite directions, has no thickness, and it contains infinitely many points. Now in our diagram here below, you'll see that this line has 2 points named. There's line or point A and point B. We would call this line L, Ritchie. So line L would be a script L. That's one way to name the line. That's probably the easiest way to name the line. The other way you could name a line is by providing 2 points. So we could call this line AB if we wanted to, and put the line symbol over. Or you could even call it line BA. Our final undefined term is plane. So think of a plane as a piece of paper or something that's infinitely large in terms of long, but it has no thickness. It's flat, has infinitely many points and infinitely many lines on it. So down in here, we've got our diagram. The easiest way to refer to this plane, we usually use a parallelogram shape for a plane, is the uppercase P, and it's typically script, but we would call that plane P. You could also refer to it as plane, and you got to use 3 letters that are non-collinear. You could call it plane ABC. You also could call it plane BCA. Now our next term is defined, and it's a segment. Here's a diagram of a segment. That's segment AB. Segment is part of a line. It has 2 endpoints, and it has all the points in between them. So believe it or not, this point A and that point B, guess how many points they have how many points they have in between those 2 points? It turns out there's infinitely many of them. It's a lot. By the way, we would call this segment AB. Notice I didn't write the arrows above the AB this time because now it has an endpoint and another endpoint. We have array. So again, here's a diagram of array. Array is again part of a line. It consists of an endpoint and all the points that go onto one side of that line. So for example, this point here, point A, this is an endpoint. So we start at A and then we go in the direction of B. So we call this ray AB. So it starts at A and it goes towards B. It would be incorrect, and I'm going to put an arrow through this because this is wrong. This is not the same ray. That is wrong. That would be actually starting at B and going in the direction of A. Again, you may already know some of these things. Finally, in terms of our definitions, we have opposite rays. So here we have, I'll just tell you what they are. You have ray CA and ray CB. So ray CA starts at C and goes in the direction of A. Ray CB starts at C and goes in the direction of B. These are called opposite rays since they form a line. You'll notice that that picture is a flat line there. For example, this would not be, those would not be opposite rays. Now a postulate A postulate is something that we just assume to be true. We can't prove it. We'll talk about proofs later. We assume that the statement's true. And so, for example, this postulate 1-1 basically says the following: through any 2 points, there's exactly one line. So if you give me 2 points like point A and point B, then there is exactly one line, in this case, line T, that goes through those 2 points. Now, by the way, you could also refer to that line as line BA or AB, but that is the same line. It's equivalent to line T. Those are equivalent. Postulate 1-2, this one says that if 2 lines intersect, then their intersection is exactly 1 point. So here we would say that line AE and BD, or DB, however you want to call it, intersect, and they intersect at point C. So there would be a point of intersection there. By the way, that point doesn't have to be drawn on there. If 2 lines intersect like that, it's by this postulate, it's assumed to be the point C. And our final postulate here is if 2 planes intersect, then they intersect at exactly one line. So here we have plane RST and plane WST, and their intersection is the line ST. The line ST is the intersection of those 2 planes. Now these are postulates, so we will assume them to be true statements. Oh, I guess I'm mistaken. I had one more. Oh, yeah. So this one's basically just saying the following. If you have 3 points that are not collinear, and by the way, non-collinear just means not in a line. Not on a line might be a better way of saying that. Let me say that. Not on a line. Like these 3 points are not on a straight line. Then they represent a curve, or I'm sorry, a plane, an exactly one plane. So points R, S, and T or R, S, and Q are not on the same line. Therefore, they represent exactly one plane. In this case, it's plane P. So let's look very quickly at a couple of practice problems. I'm not going to do all of these. Let's just do a couple of them. So let's look at A. It says, what's 2 other names for line in T? So here's N and here's T. Well, one way we could call that line is we could just use that lowercase script letter N. So that's another way to name that line. Another way you could name that line is you could call it line TQ. And there are actually other ways you can name it. That's 2 though. Let's go ahead and jump to number 3. What are the names of 3 collinear points? So this time we want them all to be collinear. Collinear means that they are on the same line. Well, let's see here. Okay, I see a couple of examples. One particular answer could be the line or the points R, Q, and S. All 3 of those points are on line L. And let's just go ahead and jump to F. What is another name for the segment RV? Well, that's simple. Just take the R and the V and switch them around. By the way, that's the only correct answer on that one. There is no other way to name that segment. Final practice problem, and let's do 2 of these. Question A, provide 2 names for the vertical plane. Okay, so the vertical plane is this guy here. So I just need to give 3 non-collinear points. So I could call it plane KHS. That might be what you would call it. So you can see that there's a point K up here, there's a point H, and there's a point S, and they're not on the line. You could even call it plane GFA. GFA. Sorry, my handwriting there is not very good. And let's go ahead and skip down here to question C. Question C. Bill states that the intersection of plane BAD, okay, that's the horizontal plane, BAD. So I found point B, A, and then D. And GFA, so that's the vertical plane. So those two planes intersect. He claims that their intersection is line DA. Michelle states that the intersection of those two planes is the line ED. Now we know that that since they've said lines that has to be true, because we know by our postulates that the intersection of two planes is a line. So who's right? The answer is they both are. And the reason that they both are is because that the line, oops, I just wrote a B, the line DA is the same line as ED. If you look carefully, you'll see that DA, which would be this line, and ED, let me get a different color ink here, and ED, well, that's this line, well, it's the same line. Anyways, so that pretty much wraps up what we needed to do for today. And now I'm going to stop sharing my slideshow, and you'll look at the next section.